name is Rick Griffith. I have a Bachelor's of Science in Computer Science from NMSU. I've been a Combat 21 developer for about 16 years, right out of college. I started with mostly as a contractor. I was a part of the Advanced Systems Technology contractor. And then when they lost the contract in about 2008, I took over with Alitech Inc. And then once I had a chance to become a civilian employee, I did that a few years ago, and that's been very rewarding. My primary focus at TRAC has been working on terrain. My first project out of college was to create a terrain feature representation for Combat 21. At the time, we had elevation files and feature files from the previous model, and they weren't sufficient for what we needed any longer. So we actually came up with a more advanced version of the terrain features, such as buildings, vegetation, and that kind of thing. I've been primarily responsible for working in that area, adding new things to the terrain features, and anything that requires model interaction with terrain features, such as like line of sight, making sure you can see out of windows and that kind of thing. And I've since branched out into quite a few areas within the model. I've done everything from GUIs to logistics, engagements, observations, just a lot of things. It's been a well-rounded career here at TRAC. And now I'll go ahead and let Juan introduce himself. Go ahead, Juan.
Thanks, Rick. Hello, everyone. My name is Juan Avila. I have been working here going on 5 years now. It all started for me when I first used my parents' computer. I enjoyed fixing the computer when something on it broke. I enjoyed installing video games and playing them. This all led me to take a general interest in computers. I then obtained my associate's degree from Doñana Community College. I then continued my education and received my undergraduate degree from NMSU. From there, I began work here at TRAC once I graduated. I have obtained the opportunity to go back to school online while working here. I went back to school to take advantage of tuition assistance and transfer credit from training. I received my graduate degree from NMSU shortly after. Since working here, I've obtained the opportunity to travel places. I've been to Virginia and Maryland. Some travel is expected, especially early on for travel opportunities, or I mean, for training opportunities, rather. I have worked on several projects, one of which was Behavior Function Mediator, which enables better integration with Python and Java parts of Combat 21. I have worked on JavaScript object notation. This is also known as JSON, which is a way to store data onto text files that can be easily read by people. I have worked on a new acquisition methodology, which will enable more realistic acquisitions within Combat 21. And that will be it for my intro. I will hand it back to Rick.
All right, thanks, Juan. So I'll go ahead and start the presentation. I've been going to be giving you a high-level overview of the Combined Arms Analysis Tool for the 21st century. This is more commonly known as Combat 21. It's one of the few times where we got an acronym that sounds cool that actually works out. I'm going to be going a little bit into the agenda first. So we'll get started. So we already had our introductions, so I'll be giving a general description of the model, some of its simulation components, and then I'll be going into a little bit about the support process for when new functionality needs to be added to the model. And then I'll hand it over to Juan, and he'll go over some of the simulation components, specific simulation components for Combat 21, conceptual view of the Combat 21 entity, and then we'll close it out by going over some skill sets that Juan and I think would be most useful for new students coming in. Things that we would have liked to have known beforehand that kind of give you a leg up for when you start here. So Combat 21 is a joint development effort by the United States Army and Marines. The bulk of the development happens here at TRAC-White Sands. The Marines work out at Quantico, Virginia, mostly on behaviors and their own scenarios and analysis of their scenarios. And then we share information back and forth, techniques and model code and that kind of thing. Combat 21 can model air, land, and sea, and amphibious combat. As again, the Marines do a lot of amphibious combat, so they use that quite a bit more than we do. It simulates at a brigade and below level. What that means for you is that it can simulate anything between a large scenario on the order of tens of thousands of entities, down to very small scenarios of just, say, a few hundred or even a few dozen entities. The simulation is closed form. That means that you set up all your entities with behaviors and missions at the start of the scenario, and you let it run until some end condition is met. This is opposed to some other models that have a human in the loop feature where an operator is actually interacting with the entities during the simulation. Ours is strictly set it up at the beginning and let it run. It's a high resolution model, which means it simulates individual entities such as soldiers and tanks, even down to like weapons and sensors. So every soldier on the battlefield is its own software object. This is opposed to some of the other models that you might hear about that are like an aggregate level. And what that means is those models won't simulate individual entities, but they might simulate an entire unit as one entity itself. This model is stochastic. This means it's statistical in nature, meaning that complex data tables store the data for all our systems, things like accuracy of munitions, the vulnerability of entities, and probability of acquisition. This is what a way the model can basically tell you what is going to happen based on the input parameters. So for something like an acquisition, you would give it information like what kind of sensor the system is using, what are the daylight conditions, what maybe aspect angle the target that you're looking at. And then we'll pull a random number from our random number streams that will kind of give you, that will determine in that case if something was acquired. And finally, Combat 21 is a discrete event simulation, meaning events happen in discrete time intervals, and the state of the objects in it are changed when one of those events occur. So everything happens in order of time. So for instance, one entity shoots, we will process that event at the time it occurs. But obviously things are happening in parallel, but that's not really how the model sees it. The model will be running the events one at a time, all the way through to the time when the simulation ends. Combat 21 is a very complex model. It's written in Java. It's got roughly 5,500 class files. That's probably even a low ball number now, and roughly about 1 million lines of code. So it is a very complex and very robust model with quite a bit of functionality. The main purpose of Combat 21 is to act as a comparative analysis tool. What that means is typically we will create a base level scenario called a base case with some input parameters that we want to have tested. And then in alternative scenarios, we will tweak those variables, such as what weapons or what sensors or what tactics we're using between those two scenarios. And then we'll run the results and do comparative analysis on the two results, or however many alternatives we have. So it's important to recognize that Combat 21 is not a predictive model. You can't set up a battle run it and then say that will be the outcome. It's more of a, you compare thousands or even hundreds of runs of the same thing, and you do some statistical analysis to say what are the most likely outcomes given the situation at hand. Okay. So here's a very high-level overview of some of the simulation components of COMBAT-21, or how we simulate the entities. Like I said, we can simulate water systems like ships, airplanes, helicopters, tanks, Humvees, soldiers. And then forces, we can model anything from friendly forces and threat forces that are just good guy versus bad guy, but we can also model things that are a little bit grayer area, like insurgents, where you may not know that they're your enemy until something they do clues you into that fact. And then we can also model things like civilians. We would tweak behaviors based on what kind of force we're currently modeling to determine how they act or how they interact with each other. And then we also simulate things like structures and terrain features like trees, rivers, roads, even down to things like communication devices, weapons, and sensors. It's important to note that each entity in COMBAT-21 is a individual software object, or made up of dozens and dozens of software objects. And each of these entities is keeping track of its own state. So there's not one master controller entity anywhere in the scenario that takes care of everything and is keeping track of everyone. Each software object is keeping track of its own state and when to update that state based on what happens to them during the scenario. So here's a broad overview of the scenario building process from our perspective. Like Ken had talked in the previous briefing, we start with an operational scenario. That is like a real world situation that senior leaders want to model and have some kind of outcome known. We start with that, and then we determine what kind of data we need to model that kind of situation. Usually there are new systems or new weapons or new sensors that we don't have data for yet, including even the terrain. We may not have the terrain that we need at the very start. So we'll actually send out data requests to, usually it's exterior organizations. Sometimes we do in-house stuff, especially with terrain. Some of that is in-house. Once we have all that data available, or we take what we have at the time, we will actually feed it into what is known as the Scenario Integration Tool Suite, or SITS. That is our COMBAT-21 front end. It's a GUI. You use that to place your entities. You use that to build your units, set up their beginning locations, and set up the behaviors that you want your entities to use. From there, the integrators will do that over usually a period of months. It really depends on the complexity of the scenario, and just how difficult it is to create the behaviors. Behaviors, we use multiple tools to create behaviors. Typically, it's one of our in-house languages, or sometimes we use the Python industry language to craft the behaviors for each individual entity. A good portion of the creation of the scenario is just like in coding. A great deal of it is debugging. So even once you've set up all your forces, you're going to have to run it, dozens of times to make sure all your entities are doing what you expect them to do. When you run the scenario, you are creating what are called logger files. These are output files that are split up by different portions of the code. So all our acquisition information goes into one logger. all our fires information goes into another logger, all our comms into another, and so on. And the integrators will use these, gigabytes of output files and a 2D playback viewer to make sure that all their units are acting as they're expected to. And that will be an iterative process to try and make sure everything works as well as it can. From there, once all the outcomes are acceptable within the time frame that we have to create our scenario, we'll then pass that off to the analysts, and they will run higher level post-processing and analysis tools on all that output, to figure out higher levels of understanding of what happened during the battle. So it may not be completely obvious what happened just by looking at tables of data, but sometimes you can glean things. Maybe you'll find out that if you take this hill, you have a very high probability of winning the battle. Or if you stop too long at this one road crossing, that can be a kill zone. So, that may not be obvious just by watching a playback, but sometimes that kind of thing comes out in the data. All right, so now I'll go into a little bit about the support process and how we determine when new code is added to the model. This usually starts with a definition of the problem from a user's perspective. This can be things like new quality of life features, fixes to an existing bug, or just to add new functionality that hasn't been added before. These requests will then be resourced and prioritized as appropriate within time and mission constraints. This will again be a collaborative process between the requesting point of contact and the model developers. So we may go back and forth multiple times to say what is feasible in the time frame and how robust it needs to be and at what fidelity we want to run it and those kind of things. Then the development process will begin. Sometimes we have a detailed list of requirements and sometimes not. Again, we'll work with appropriate individuals to figure out what needs to go into the model. So this may include users, data people. We may look for existing algorithms, say, for example, search algorithms. If they've already been created, we just have to, basically put them into code. And then we come up with a solution that will work. From there, we will write any tests that need to ensure the solution meets the expectations. Usually this is in the process, or usually it'll be something like unit tests or even small test scenarios with a few dozen entities. If we're testing something like a formation move, we may just have one unit and put them in formation and test and see if it works at a smaller scale before we do some more rigorous testing later on. Our testing process, each developer will basically do a very, very rigorous testing of that code. Typically, we want to make sure it looks like it's going to work from the outset before we put it in the code base. When it passes our initial test, we'll provide inline documentation to the code, and we'll also document the code on side of our, what you would call a wiki space called Confluence. And then once all that documentation is done, then we'll commit the code to the code base. The next step is the developer and the configuration manager will ensure that code commit was successful and didn't cause any compile issues. A common, well, not so common, but the most common thing that'll happen is the developer will forget to commit a file. Maybe it's a new file or even database tables sometimes. And if they don't get committed, then it won't compile correctly and work. So the configuration manager helps us with that. From there, it'll go to our testing team. What will happen first is the testers will run a series of automated tests. Tier 1 tests are made up of unclassified testing scenarios that usually test just a few similar functionalities. This is similar to like the developer tests. It's usually a very small scenario that only tests one thing to try and limit the variability within that scenario. And then if all goes well there, then we'll start tier 2 tests. Tier 2 are classified scenarios that are production level scenarios, typically with thousands of entities, that was used for past studies. We'll run the new code against those past studies to make sure that everything still comes out okay. Testers and the developer will look for output changes in all the loggers for tier 1 and tier 2 to determine if any of those things that are changed are expected and correct. And then we'll mark that build as either a pass or a fail. If the commit passes, the test team will verify the documentation has been added and that an independently built acceptance test wields the same results as the developer test. So usually the developer will come up with a list of instructions for the tester to do independently, and they will try and replicate what we did when we built our test. The code base will be marked standard if there are no output changes. This means usually a new functionality that isn't tested by the code base, but it can be just improvements that you may not see any changes to the output for. It'll be marked as benchmark. That's if there are code changes or are output changes, but we can justify them, such as when you fix a bug, that will usually change all the output for a given scenario. And then finally, if the build fails, if we found something to be wrong with the commit, or it didn't fix the bug the way we wanted it to. And then over certain time intervals, the test team will go through some more tests and make sure that everything seems stable. And then once that happens, we mark that particular build as stable, and we'll pass that off to the actual users for their testing. So that's where we declare all the build types. And then the very final stage is usually when we give it to the integrators, our users, and they will run their own tests, usually against their scenario, to make sure that everything looks right and it acts the way they expect it to. Okay, so that's the end of my portion. I will go ahead and pass it off to Juan to talk about some of the Combat 21 architecture.
Thank you very much. We can model several things within Combat 21, things like the environment down to individual entities. These are represented as individual objects, with each object capable of keeping track of its own state, like amount of rounds or current damage. Some environment objects that we model are terrain, weather, vegetation, rivers, oceans, buildings, and doors. Some entities that we model are tanks, aircraft, ships, amphibious assault vehicles, and infantrymen. Next, I will talk about the object representation in more detail within the model. There are different modules for different tasks that an object may perform. Things like logistics, mobility, communication, observe, engage, and damage. These modules have different components to it. One is a decision module and the other is a functional module. The decision module will handle the decision-making parts of the code, while the functional module will handle the action part of the code. Just to give you an example, if I was a tank and I wanted to engage an enemy target, I would first need to observe. Then I would have to decide based on my current information if I am within range. if I have enough rounds, if I have the right ammunition to engage the target. Then from there, I would decide to engage the target, which would be done within the decision module. Once the decision module makes a decision to engage the target, the functional module takes care of the part that actually fires a round at a target within the code. Because entities hold their own state independently, a mediator object will handle interactions between the two entities by taking information from both and calculating things like damage against the target. If the mediator decides that the target got destroyed, it would send information back down to the entity so that the entity may update its state with that new information. So that was a brief overview of model architecture. Next, I will discuss beneficial skills if you want to become a model developer. Here are some beneficial developer skills that would give you a leg up to work here as a developer. A strong skill would be a 4-year college degree in computer science or in a similar degree field. Object-oriented programming is a good skill to have. In particular, we use Python and Java. Using an IDE will be beneficial since we would be using NetBeans here primarily. Other useful skill to have would be working with a database. Particularly, we use SQL, but any experience with database will do. If you work on projects in school with others, that would be highly beneficial since when working here, you will be working with others the majority of the time. A course in AI or agent-based simulation would be helpful since these are becoming increasingly important within the modeling community. A statistics course will be helpful because this is a tool that is used to analyze outputs of the combat model simulation. Often overlooked skills are speaking to an audience and communication skills. I would not have imagined that I would be presenting to others when I began working here. So a communications course has helped me in this regard. I would also not have imagined that I would be writing technical documents, so taking a technical writing course was helpful for me. This concludes our presentation, and we will open it up for questions.
That was a great presentation, and I especially loved the last slide, you guys. I did not find it boring at all. Any questions from the field?
Hi, I have a question.
Go ahead.
Hi, this is Mario. So for the Combat-21 simulator, you mentioned it was simulating Army and Marine kinetic movements. I was kind of wondering if the simulator also involved more of a cyber aspect to the warfare, or is it more of the kinetic movements of the warfighter?
Yeah, that's a great question. We are looking into doing cyber. I can't speak to how far we've gotten with that. It's been looked at a few times over the years, so it is a very important aspect of battle space going forward. So anyone with any interest in cyber is welcome to come on board because we can always use people for that. I know we've had a few developers look at it. I think some of that is we're waiting for algorithms to be approved so that we can actually put it into the model.
Is there anything else that anybody has a question about?
Yeah, I have another question. I'm not sure exactly how to formulate this, but you're mentioning some of the assets you use, such as like air, land, sea assets. As far as air goes, does that include like satellites as well, or does that not usually pertain to the scenario?
We technically do have a space module for Combat 21, but it's never been hooked up to use for a study. Again, at this point, we haven't had a study that I know of that's required space satellites or anything like that. But I mean, the model could handle that once we had enough, information with data or algorithms that we could model space, space entities.
Hey, Rick, this is Rod. What I would also add to that is that, as Rick mentioned, we have the module. It's just that there hasn't been a demand for representing aspects of that module in an explicit fashion. And as you can imagine, there can be sensitive data associated with that. Typically, we will do implicit type representation associated with how that satellite operates and provides information to support whatever that satellite may be supporting. Over.
Sweet. So is this scenario also only considering like American assets, or is it also considering its allies and partners and maybe other unforeseen assistance or targets?
Well, Rick was going to answer. Go ahead.
Yeah, maybe I'm not the right person to answer this question. We certainly can, and I just don't know if we have. Like I said, there's no we can define our forces however we would like. Basically, it's just a different side. So we certainly don't have to think of things as just American forces against everybody else. We can represent any force. Like I said, including like insurgents or civilians. So another army of a different country certainly could be represented in Combat 21.
Anybody else have a question?
And hey, Stephanie, if nobody else has any questions, I did actually come up with a few things that I would have wanted to know coming to work for TRAC beforehand that our audience may be too shy to ask for.
Perfect.
So if anyone has any questions, please ask them now. Otherwise, I'll ramble for the next few minutes. Okay, so I'm going to go ahead. So some of the questions I wanted to know when I wanted to come work for TRAC is how collaborative the environment was. Were the developers going to be competitive? And I would say that I was happy to find that this is a very collaborative environment. I was welcomed by senior developers immediately. I was able to ask them questions when I didn't know what to do, and they would always help. I've tried to pass that forward with newer people. So it's not a competitive environment. We're not trying to undercut anyone. The organization succeeds when its individuals succeed. So even across different groups, you'll usually find that you can ask questions and people, when available, will be able to sit down with you and give you explanations on things that you don't understand. So it's not necessarily a sink or swim environment where you're immediately put in the deep end, and if you don't, pass muster, then you'll drown. People will try and help you succeed here. I would have also wanted to know how it was looking at track, I'm happy to find super stressful. That's not always the case, as with any job, but your day-to-day is not you wanting to like tear your hair out. Most of the time, you have enough resources and time to complete the projects. When we get closer to deadlines, you may have to put in a little extra time, and depending on where you are in the process, it may be a few hours over a few weeks. It just depends, but it's not crunch time like it's in industry where you're putting in 60-hour weeks every week for months. That has not been my experience here at all. I know some of the integrators have to put in a little more time more often, especially towards the end of scenario development, but I would say it's much more manageable than what you might find in industry. The last thing I thought of, especially when you're starting with the Army, if you've never been exposed to it, how complicated is it to understand all the jargon they use? I will say it will take you a little while. There are acronyms within acronyms within acronyms, and most of that will not mean anything to you for a very long time, and that's okay. You'll pick up what you need to pick up, and everything else will just become letters, alphabet soup that you don't have to pay attention to most of the time. So that's all I had. Thank you.
Yeah, I'm gonna jump on what Rick said there. I came here after about 7.5, 8 years in the Army, and I still had a lot of acronyms to learn. So it's a new environment for most people when they start here, so it takes a little while for you to get up to speed. And we all recognize that it's going to take you some time to learn.
Any more questions out there? Feel free to jump in.
So as far as like various degrees go, how would you say, for example, an electrical or mechanical engineering degree relate to the type of work that you do?
Well, I know we have quite a few people that have varying degrees. Mostly, if you become a model developer, the degree won't matter so much, but some programming experience will be important. As I said, it's an object-oriented model. It's just going to be the reality of the situation that you'll have to have some coding background, and probably the more the better. Like I said, you don't necessarily have to be computer science. We've got math majors and other engineering degrees, but some programming experience is likely going to be required if you want to jump into the model development portion. Not so important if you come in as other positions, then that programming is not quite as important.
And which languages are most beneficial, Rick?
What we use directly is Java and Python. Java is all the model code, where Python is mostly our behaviors. Any kind of object-oriented programming is probably fine. Been so long since I've had to do like C++ or C#, but if you are really good in those languages, Java is not going to be any great hurdle. Same with Python. I mean, non-programmers can usually start with Python if they have some logic background. So those would be the languages I would expect would be most useful.
And then I guess another question that might be out there is, does everything TRAC work on run through the COMBAT-21 model as far as studies go?
No, I don't believe so. We have other models. Obviously, our cost people, they do something different than Combat 21. We have multiple groups in TRAC that all have their own jobs that don't necessarily touch Combat 21 at all. I would say Combat 21 is probably one of two of the main models that TRAC uses, at least locally. The other being OneSAF. That I don't know enough about that team to speak really well about it. I know it's a smaller team. I believe OneSAF is also a Java programmed language model, but I know they're considerably different than us, so I won't speak too much just because I'm kind of too ignorant on OneSAF to say to not say so dumb.
Excellent, thank you. Rick, did you have something to jump in on?
No, I was just going to be available in case you need to back him up any. So I do have a very small OneSAF team that works for my group. You could probably do some Googling and see learn something about OneSAF. It's a model that is used Army-wide, whereas Combat 21 is developed in-house at TRAC. It is used by other agencies, but the important part on OneSAF is so it's ONE, O-N-E, and then SAF is an acronym for Semi-Automated Forces. So that's a model that you can run interactively. So you can have decision points where folks can, role players can come in and make a decision specific and that, let that change the flow of the rest of the battle. Where Combat 21, you have to make all those decisions beforehand and set them in there to allow the computer to do those type decisions within it. And I'll toss in there. Some studies don't require a model. We did a evaluated MDO operations in UCOM theater, and we used a visualization tool as all, and warfighters to do a war game and produce results from that. So a lot of different kind of ways that we approach analysis. Some are, matter of fact, some of them are a little more than gathering the information and consolidating and presenting the information. So we span the gamut. That's all I got.
Okay, great. I think that's a good place to end it. We're starting up again at 1:45 with Combat 21 SITS and Scenario Integration Overview with Mr. Energene. So we'll take a very quick brief. Thank you so much, Rick and Juan, for your briefing. I know that I found it very interesting, and I'm sure the students did too.